So, logic to it. Because it's like I said, this is for integral inequalities. Inequalities. All right, integral inequalities. So we've got our log y equals ln x, and what they've discovered is if I take, which is very simple, if I take let's say rectangles below the log curve, right, infinite amount of times, I'll always have a little bit at each section that's missing. I'm sure you guys can see that, right? And then the logic to it is the thinner the thinner the widths, the less error I would have. So i.e. the closer these get to the exact curve, right? So does that first logic make sense? If I was to sum through these little areas, this is lower than the exact curve, the area from here to here of the exact curve. Does that make sense? You guys? Yes? No? Confused? Ben, does it make sense?
Yeah, it does.
So what am I trying to get to? I'm saying that the areas below
Yes.
are obviously going to be less than the area of the exact curve. Correct? Because you're going to have a bit of error. All right. And then what they saw was if I take this particular width, if I go just a bit to the right, and same thing here, and same thing here. So i.e., you have this whole rectangle. Just imagine that was a whole green one. This one here, this one here, this one here, and so on. The green one will obviously what? Overestimate the exact curve now. Right? This green curve will overestimate the exact, and obviously that would be a lot larger than the areas below. So if I said this first one was 1, 2, 3, or actually even better yet, let's say this was n, and the one next to it was n plus 1. n plus 1. What's the width? What would the width of this be, of this rectangle?
2n plus 1.
Nope.
Wait, what?
This is n, and then this is n plus 1. What is that width? Just 1. You're at n, you're going to n plus 1. Your width is 1. Isn't it? If you started at 5, now you're at 5 plus 1, your width is 1. How would you work out your height? How do you work out your height? Well, you guys can see that at n, your height is log, so like your y value, the y value is ln x, right? So you're going to sub in n, and you'll find that height, which would be log n, log n. Do we understand what I've just done there? I substituted the x value, went up, and now I know my width, my height of my rectangle. Anouk, does that make sense?
Yeah.
So what would the height be for this next triangle, pretty much? Or the height, triangle, rectangle. What would the height of the next rectangle be? Anouk, any ideas?
Not really.
Well, where is it touching the orange curve? Right there.
Yeah.
So what's that height? Well, that would be log of n plus 1.
Oh, okay. Yeah, I see.
You see that happening? And the next one. The next one's n plus 2. So what would the height of that be technically? Log of n plus 2. Does that make sense?
Yeah.
So area of one of these is log n, and then log n, and then sum of areas below curve, sum of areas below the curve would be log n plus log n plus 1 plus log n plus 2 plus log n plus 3 plus ... for now. Do you get that? Girls, Mariette, are you confused at something?
No.
No? It's making sense so far?
Yeah.
Okay. I'm going to do the exact same thing for the area above. So let's do that in green. So let's find the area of the longer ones, the ones above. Again, what would the width be? Well, the width is still 1. Right? What would the height of the green one be? Mariette, what do you reckon? What's the height of the green one? Where is it touching the curve at the highest point? Is it at n or n plus 1?
Is that n plus 1?
Yeah, good job, right there. So it's actually at log n plus 1. That's your first one. Log n plus 1. So technically these ones are going to look like this. Log n plus 1 plus log n plus 2 plus log n plus 3 plus ... for now. Sum of areas above the curve. And last one, what would the exact area of the curve be? Exact area of curve. It would be the integral, let's call it from n to, I haven't said where to stop, but we'll just make it to k for now. So it'll be from smallest is k, largest is, yeah, no, other way around. Smallest is n, largest is k, and then of course the curve is ln x dx. I'm going to pause there. Seriously, any questions at this stage of the logic behind these questions? So, area of, rectangles, or some questions you will see are trapeziums. So, rectangles or trapeziums. How would you know the difference between the two? Trapeziums you're going to see like over 2. That would be the trick to it. But majority of the ones we're going to probably be looking at are more rectangles for now. Because trapezium get you even closer to the curve. So we found the area of the smaller ones, we found the area of the larger ones, we found the exact area, and then pretty much the conclusion you'll be making is something like this. And this is what you're going to be dealing with a lot. Area below is less than, exact is less than area above. So area below less than exact, less than area above. Let me know once you guys are ready to move on. I will start a question now. So a bit of a different logic than I guess what we were doing last week. All right. Anyone copying anything down still? Okay. All right. Maybe you might be able to see it even better now. So, the area of the region under the curve y equals 1 on x from x is n minus 1 to x equals to n is between the areas of two rectangles, right? The exact area of this curve from here to here is the area between two rectangles. Show this. So again, you either know what you're doing, so you can do it, or you don't. Now, to get to this is going to require us to do some rather unique stuff. This was worth 3 marks or 4 marks, and it was question 8, which is the last question of the HSC. So we will do some unique things, which you will get used to in due course. But I just want to make sure we get the logic clear. So, Ben, you're going to work with me with this one. Tell me.
Okay.
Let's do the blue one first. Let's say. So what's the area of that?
It's just 1 times ln.
But there is no ln.
N minus 1.
But
Oh
there
wait.
is-
Oh wait, it's an e. No mind. Yeah,
It's
it's
not
an
an
e.
1 on x.
Oh, dude. Okay.
True. Careful.
Yeah,
It's a
you're right.
function.
Okay.
So times by. Think
Is it
about
n minus 1? Wait.
Think about the width. The width you've got is 1. Now
Yeah.
think about the height. If you're saying n minus 1, n minus 1 looks like it goes all the way up here and touches the curve.
Yeah. Oh.
So what's this width?
Oh, that's just 1 on n.
Height, sorry. 1
1
on?
on n, right?
Yeah, 1 on n. So it's the opposite of what you usually would think. The first one down here is just going to be 1 on.
My brain.
Good. Then, what about the area of the orange now?
That's just 1 times 1 on n minus 1.
So that's that. And then, obviously, the exact area.
Is the integral of
Integral
something.
of 1 on x. 1 on
Yeah.
x. dx from where to where? From n minus 1 to
n.
n. And then the inequality is what? It's 1 on n
The area below. Yeah.
must be less than the area of this, which must be less than 1 on n minus 1. You think we get that now? The logic, again, not so much getting it all out
Yeah.
straight away, but the logic. Because obviously it's very different to last week.
Very.
Okay, what do you think you'll do now? You're not going to do anything to the left, you're not going to do anything to the right. What are you going to do?
Am I going to integrate that?
Yes.
Oh
What's
no.
the integral of 1 on x?
It's a log x.
Log x. And then you have n and n minus 1. Next line. 1 on n. Less than log n minus log n minus 1. Now you can see a whole lot of e's here. You don't have any e's, so you know what you've got to do with this. This is a log law. You're allowed to divide.
Yeah.
Now what are you going to do to everything?
You're gonna eat everything?
You're going to eat everything.
I
Correct.
think.
So it's going to look like
Yeah.
this. E to the 1 on n on n minus 1 less than e to the 1 on n minus 1. I'll let you guys just copy that down. I'm going to pause there. Screenshot of what we need to prove, so you guys can see how we're going to do this. What I have, what I need. What I have, what I need. All right. Okay. Okay, can you see this middle bit? If I made it into a common denominator, I actually get n minus 1 on n.
Uh-huh.
So that's kind of annoying, isn't it? Isn't this middle the reciprocal of your middle?
It is. Yeah.
It is. So therefore, you can't keep it like this. You just found out what to do. You have to literally. You're going to reciprocal everything. So, all right, it's going to look like this. Now, this is going to be e to. Technically, if I'd made this into a reciprocal, I just want to show you guys. You know, you get this, which is an index law. It can come back on top as negative 1 on n. In other words, it becomes e negative 1 on n. Now, if you reciprocal something, think about again. If 3 is less than 4 is less than 5. 3 is less than 4, less than 5. Is it true that a third is less than a quarter is less than a fifth?
No.
No, it's a third is bigger than a quarter, bigger than a fifth. So you got to be careful. So then that becomes like this, which we will rearrange in a second. So let me write that. Let me write reciprocal. And then rearrange, make it look better. We're very close, Ben.
It's,
Look at this. Look at this. What do you think I'm going to do next?
you're gonna split the numerator.
You don't need to. You don't need to necessarily split,
Oh, just like
because we're going to do that in a second, but we don't need to necessarily split. See, Tiger.
okay. Oh, you're gonna
Say it again.
wait.
Look at it. Look at this, and look at this. Something's different.
You're gonna times everything by n.
You're kind of right.
Oh,
You're going to
yeah,
go power of n.
of n. Yeah.
Yeah, power of n. Power of n. Power of n. Power of n. These two cancel out. Boom. This becomes exactly like you want in the middle. Now you can just write the question because you already realized that was this. And then that just becomes e negative n on n minus 1. Done. Now, because every question is pretty much like this, I'm going to get you guys to do that again. So copy it down, then try to start from the beginning, and literally try to execute and tell me where you guys get stuck. So, but every single question is exactly the same. Okay, I'm gonna pause. Let's stop that recording. You don't need to